Well, hello students. I just wanted to send you a quick video about the Unit 5 review. Given that it's Christmas, I thought it was fitting to use some Christmas colors, our green and our red. So here we go, and enjoy the video. So the first thing we're going to review is changing a mixed number into an improper fraction. So we're going to use a mixed number of, let's use 2 4/5 as an example. Remember, a mixed number is a whole number. In this case, it's 2, and then a fraction, which is 4/5. We're going to change that into an improper fraction. Remember, an improper fraction is where the numerator is bigger than the denominator, or the top number is bigger than the bottom number. If you're trying to remember this right here, remember that the definition is like Notre Dame, ND, and on the top, the numerator, denominator on the bottom. So when we look at this here, you could visualize it, and you could say, okay, well, I know that part of my fifths aren't perfect. I know that 2 wholes is the same thing as 10/5, and then I have 4 extra pieces, like so. So I know that this equals 14/5. Now, that works sometimes if you're able to visualize it and say, okay, I can shade these all in and count them up, but it's not really the most realistic way to think about this. The best way, in my opinion, is once you've got this conceptual understanding, is to just multiply the denominator by the whole number, so 5 times 2, and then to add the 4 up top. This is the method we talked about in class. Now in the bottom corner here, I'm going to show you one where we can go from an improper fraction like 49/6, and we can convert that over. I'm asking myself, how many times can I take 6 out of 49? And I can take 6 out of 49, not 6 times, excuse me, 8 times, because 8 times 6 is 48. This is where the multiplication facts are so important. Now I have 1 left over, that becomes my numerator, and the denominator always stays the same. In your mind, you might actually see me doing that motion of that denominator always staying the same. Notice here the denominator stayed the same. Notice here the denominator stayed the same. Unless we reduce, the denominator will always stay the same. Okay, the next concept that we're going to go over is using 10 and 100. We teased in class a little bit and said, you know, the power of the 10 or the power of the 100. Kind of we were talking about the power of the force. But using 10 or 100 as the denominator is so key. When we look at fractions like 23/50ths, 4/25ths, or 9/20ths, we see fractions that end with denominators that aren't necessarily super easy to work with. Sure, we might have learned the unit fraction of 1/50th and said, yeah, it's 2%. But now we have 23/50ths, not as easy to work with. If we were to change these fractions over to ending with, so the denominators were 10 or 100, it would make things a lot easier for us. So I asked myself, how many times, 50 times what is going to equal 100? 50 times 2. Now, even Stevens, remember, we want to do the same thing to the numerator as we did to the denominator. So when we multiply that together, it's 46/100ths. Now, this is really easy here. 46% and 0.46. Remember, whatever this numerator is, just like our ESPN project, that's what the percent and the decimal is. For the two below, 25 times 4 is 100, and 4 times 4 is 16. 16/100ths, which equals 16%, and 0.16. Lastly, we have 9/20ths. 20 times what is 100? Well, 20 times 5 is. We do the same thing to the top, to the numerator. We have 45/100ths, which is 45%, or 0.45. What you can notice here is on every single problem I showed my work. One thing that shows a successful student is a student that will show their work on all the problems, even if they think they have it inside their mind. Just earlier today, I made a mistake where I forgot to write this down. I was kind of being lazy, and then I wrote 4/100ths. I forgot to multiply the top just because I didn't write down my work. So always write down those steps there. That's so key to being successful. Okay, this is the last slide that we have for this review video. The first concept that we're going to talk to is the one on the right here, or excuse me, the left, which this is reducing fractions. I'll write that at the top so we remember. Reduce and simplify. We want to reduce these fractions as small as we can make them. Now, something that you'll want to note is anytime you have two even numbers, you can always divide by 2. That's a good place to start sometimes. So we'll actually start there for our first one. I'm going to divide these by 2. Notice how I'm writing out my work. 7/13. Now, one thing that I notice here is 7's a prime number, which is typically a sign this is as small as this can be. 13's prime as well. And it actually is. There's no number that I could count by or multiply by that would hit both 7 and 13. A good way you can check this is counting by some small numbers that might be a factor of both 7 and 13. For example, you'd say, well, maybe 3 would. 3, 6, 9, 12, 15. Well, it didn't hit either one. So 3, you can't divide them by 3. 7/10. This is actually kind of a trick one. It's actually as small as it can be already. So 7/10 is as small as it can be because I can't count by a number and hit both 10 and 7 at the same time. 7 is prime, which tells me, it's a clue that it's probably as small as it can be. Lastly, we have 12/20. See, I know both of these are divisible by 4. If I count by 4, 4, 8, 12, 16, and 20, I'll hit both of the numbers. So 12 divided by 4 is 3, and 20 divided by 4 is 5. Well, 3/5 is as small as it can be. So this is just an example of how to simplify these fractions. Remember, not everyone can always be simplified, but many can. Lastly, on the right side here, we have 4 different fractions. Now, without using your calculator, how could you order these from the least to the greatest? The best way to do this is to compare them and say, what is it as a percent or as a decimal? I'm going to write what the decimal is for the time being right now. Now, we memorized earlier in the year that 1/8 is 0.125. I can write that in. 7/10, well, I know 1/10 is 0.1, so 7/10 has to be 0.7, 7 times that amount. 1/2 is 0.5, and 3/5. If I know that 1/5, I'm going to kind of draw, this is me right here. This is my mind, ... If I know 1/5 equals 0.2, well, then times 3 to get to 3/5. 0.2 times 3 is 0.6. So 3/5 has to be 0.6 here. So, okay, I'm going to erase my mind here. You really don't care what my mind thinks anymore. So next time I'll use a bigger eraser. So now that I know the decimals, I'm going to compare that first placeholder, which is the tenths. So the 1, the 7, the 5, and the 6. And in this case, I can do it all at once. The smallest one is 1/8, which is 0.125. The next fraction is 1/2, which is 0.5, followed by 0.6, which is 3/5. And lastly, 7/10, which is 0.7. If you have any questions, feel free to shoot me an email or give me a call. You have my email and my phone number, 616-212-7413. I'll be here early before school tomorrow if you have any questions. I know that you'll do very well. You guys have worked hard, and I expect the result to be really well. I love you so much. See ya. Have a good afternoon, evening, or morning whenever you're watching this. Bye-bye.